Here I'm going to introduce the concept of phase diagrams. Now, phase diagrams are a diagram, and we're going to focus on graphs that show the state of matter, the phase of a material or substance under some conditions. The conditions might be as temperature changes or as pressure changes. Obviously, well, most people know this, that certain phases of matter, the states of matter, we have gas, liquid and solids. Most materials will go through those, especially if they're pure substances. Carbon dioxide goes directly from a solid to a gas. There's no liquid state under standard pressures. So we're just going to focus on this example, which is a glass of water, just to show what happens as we cool it down. So I'm going to start from 20 degrees Celsius. Here it is, 20 degrees Celsius. I think most people would remember that water freezes at 0 degrees Celsius. And if you read up any science books, junior science, you'll understand that that temperature will remain at 0 degrees as all the energies change the phase from liquid into ice. Okay. So starting from 20 degrees Celsius, what happens as it cools? Okay, nothing interesting. The phase stays the same. Okay, so we're starting with the phase of water. We're not interested in gas at this point in time. It cools, nothing happens, it just simply cools. The temperature gets lower and lower and lower and lower and lower. It's all liquid, still liquid, until I get to 0 degrees Celsius. And as I said before, at 0 degrees Celsius, we start getting ice being formed. Okay, let's get rid of that. Now, just here, we see little nucleation of ice crystals beginning to form. What happens to the temperature? Okay, as we said, especially in the controlled situations, the temperature will stay the same, 0 degrees Celsius, but the amount of ice will grow. Here we've got little nucleation bits everywhere, which is going to happen. These ice crystals are going to grow more and more and more. Temperature still stays at 0 degrees Celsius. Ice crystals begin to grow. So we have two phases existing at the same point in time here. We have liquid water and we have solid water. Temperature still 0 degrees Celsius. That ice is going to continue to grow. Okay, here it's growing further again. Temperature stays 0 degrees Celsius. We're just getting more ice and less water. And again, more ice, less water. More ice again. Okay, and here we are with 100% ice. So we started with 100% water. Now we've got 100% ice. What happens? Well, okay, now we're 100% ice. Now we can cool that ice. Okay, so the ice is going to go further and further, get colder and colder and colder until it gets down to negative 20 degrees. Or further. It's just for this illustration, we're sticking it from positive 20 to negative 20. Now, what does that mean in terms of a graph? Let's just change that. Let's make it a bit thicker. Okay, if I got temperature on that scale, let's say we got a 0 degrees Celsius there, and this is time on that scale, on that axis. We would start with plus 20, and our interest is finishing at negative 20. And it's all degrees Celsius, of course. As we showed before, the temperature, and depending on how you cool it, we're cooling it nice and controlled. It's slowly taking heat out of the substance. The temperature just decreases, and we'll make it nice and easy. Let's just pretend it's a linear change. Well, not pretending, we've just made it linear. That's the rate at which we're taking the energy out is constant, so the temperature changes in a constant way. And nothing happens until all of the water has turned to ice, and then we can cool it down even further. Okay, so here, oops, we've got the cooling curve of liquid, and then it becomes more and more solid, and here it is all solid. It is the cooling curve of solid. I've just indicated there that if we're taking out energy out at the same rate, ice doesn't have the same heat capacity as water. It's a bit less. I think it's half of it or something like that. So if we're taking energy out at the same rate, it's going to cool down a bit quicker, but that's beside the point. Okay, so let's just go through a few small things here. Here, the phase is all solid. Sorry, what am I saying? Here, the phase is all liquid. Okay. Liquid. Here, it's all solid. And in between, we have liquid and solid. Okay, nothing to it so far. Piece of cake. That's the end of the first lesson. Next lesson we're going to look at what happens if we don't have the pure substance, if we're mixing two things together.